Okay, so how do you build an AI application? How do you build, for example, a computer vision application, but this equally applies to everything? First, you need the data, then you need to label the data, then you train your model, and then once the model is trained and once it works well, you need to actually deploy it in the application, right? And my talk today will be focused on the first two parts of this life cycle, on the data and on the annotation. So, about the data. Actually, the availability of large data sets was one of the major driving factors of everything that we have, of all this proliferation of deep learning that we are experiencing, and of the deep learning revolution that happened 10 years ago. And you know, if many of modern neural network architectures were actually invented back in the 1980s. And if you take a neural network from, I don't know, 1992, and you just scale it up, and you train it on modern hardware, on modern data, well, it kind of works. Naturally, our modern models would work even better, but still, the problem with this second AI winter, the problem with this second crash of over-promising and under-delivering in AI in the early 90s was basically due to not enough computational power, not enough scale, not enough data, especially the data. And by now we have large data sets available for many problems. Quick show of hands, how many of you know what ImageNet is? ImageNet? Many people? Okay, quite a few. So ImageNet is a huge data set for image classification, basically. And almost every computer vision model at some point gets pre-trained on ImageNet before it is being fine-tuned for a specific application. But still, for every specific application, you need to have a data set, and this data set has to be labeled for this specific application. For example, if you want to do object detection, you have to have your photographs, and you have to draw these bounding boxes around the objects. And if you want to do segmentation, if you want to do the silhouettes of the objects, then you have to have a training set with the silhouettes, right? And inevitably, to label real data, there should be a human in this loop, right? And this is a very laborious process, and it costs a lot of money, and for some problems, it is just completely impractical. So, what we do at Neuromation to try to combat this problem of not enough data, which is actually the problem, the major problem of modern AI, for many tasks, for many applications, we have models that are basically good enough. They will work, given enough data. But the data is the bottleneck very often. So our approach to this is to use synthetic data. And I don't have time to delve into other fields, so I will concentrate on computer vision. For computer vision, synthetic data is what it means. It's very simple. It's a three-dimensional model of the object that you want to recognize. You do it standard CGI stuff. There is manual labor involved here. But once you have invested this upfront manual labor to get the 3D model, then you can get the renderings of any scene you want with these objects, right? In any combination, in any number, with any background, in any scene, in any combination of different objects. But that's not very surprising. But what's really good about the synthetic data approach is that this data comes with free labels, right? Because that's the 3D scene that you yourself set up. So you control everything, you know everything, and you can actually, so you obviously know where each and every object is. You know what object each and every pixel of your render belongs to, so you can do pixel perfect segmentation, like on the second picture here. You can do object detection, the bounding boxes like up here. But even more, you know some things that a human being just cannot label, and that are not available for manual labeling too much. For example, depth estimation. If I give you a photograph, you can't really estimate the distance to camera, right? You can vaguely say that this pixel is further away than this pixel, but it's very hard to estimate the actual distance. Again, in CGI, you get it for free. You know where the camera is, right? And similar for occluded objects. If my hand is behind this counter, you don't know where the hand is, but if it's a 3D model that I set up, then I do, right? So there are all sorts of labels that would be very hard to obtain manually, but that go basically for free in synthetic data. And this scales up, right? You can easily add new objects. And once you have, for example, the model of a cow, you can just add a different texture, and here you go, you have a different cow, right? And you can slightly modify, you can randomize the models, you can do all sorts of things. And also, you get a very, you get to introduce a new kind of diversity into your data set, right? So this is another, this is another important benefit of synthetic data here, because because maybe it sounds to those of you who do computer vision a bit like data augmentation, right? So data augmentation is also you take a picture that you know is labeled and you do some transformations like up there. Transformations such that you know how the label changes. So for example, you crop the image and now you know where the objects are in the cropped image. Well, with synthetic data, you can do very different kinds of transformations. You can do much more flexible transformations, much more interesting things. And basically, you can generate an endless stream of new images that give you whatever you want. And I will not go through the whole of this slide, but you can change all camera attributes, you can change environment attributes, you can change the scene, the complexity of the scene. You can do anything in this 3D environment because you control it perfectly, right? We've covered this already. And there is already a number of applications where synthetic data is increasingly used. And actually, historically, it began with autonomous vehicles, with the self-driving cars, and with robotics. Because in these kind of applications, you often want to train your model with reinforcement learning. And for reinforcement learning, you need to have an environment where an agent can act and see how the environment responds. And for example, for a self-driving car, it's kind of obvious that you cannot do it in real life, right? You cannot get a car out on the streets and let it learn not to hit pedestrians by trial and error, right? So in this kind of applications, it was immediately obvious that you need a simulated environment. So in these kind of applications, they started with this immediately. But over the last couple of years, synthetic data has been catching up to all sorts of computer vision applications, to face recognition, to gaze estimation, to retail applications, which are basically object detection for a lot of classes. Very, very many interesting applications here. And there is another twist to this topic, right? So, of course, synthetic data is not perfect, in the sense that once you have trained your model on synthetic data, you have to apply it to real data afterwards. So your test set and your actual application, your actual inference of the model will be done on real data, not on synthetic. So this raises a domain adaptation or a transfer learning problem, right? How do you train a model on one kind of images and then apply it to a different kind of images? How do you train on basically renderings of 3D cartoons and then reapply it to real photographs? And that's basically the whole that's basically the topic of our research at Neuromation. So I will not go into the details for this. We have done, now the advertising part comes, I have 1 minute left. We have done a large project for a retail provider who had tens of thousands of classes of objects, and it was just completely impractical to manually label the data set. So we did synthetic data for this. We did synthetic faces to increase the diversity in face recognition, face verification data sets. So as you can see, now the problem is a bit different. You are not trying to recognize this guy because this guy does not exist. You are just trying to add more data for the model to train on to improve its generalization and then recognize real people. And we are a growing company. We do synthetic data. We do a lot of research. Please check out our blog. I write neuronuggets about all sorts of things, deep learning. We have great guys. And with that, I thank you for your attention.